So we have a small group, which means you get the best information you can get, of course. So my name is Robert Scholte. I'm the chairman of the Apache Maven project, and I'm going to talk about Maven, of course, and Java. So, first of all, I added a little bit of orange to the slides. I'm from the Netherlands, and tomorrow is the birthday of our king. And to give you a small impression about how that looks like, this is what's going to happen tomorrow. So everybody is dressed in orange, having party, yes. So I have to miss it because I'm here. I will be there again next year. So it's every year. It's totally crazy. So I had to add a little bit of orange to the slides. So that's the reason why. So let's go. So the good news is, ta-da, Maven runs fine on JDK 9. So this was one of the questions Mark Reinold was asking on Twitter when Java 9 was released, and asked every Java project to say, well, if you run fine on JDK 9, just let us know. So Maven does, also on 10. For Java 11, Mark Reinold asked exactly the same question, but in this case it works like heaven on JDK 11. Again, Maven works fine. Also on 12 and also on 13 early access, which I have on my machine as well, and I'm going to demonstrate that. The issue is not Maven. If there are issues, they are probably related to the plugins. I can also show you that Maven 3.0 also runs fine on 13 early access. So in general, if the maintainers of these plugins are capable to solve this Java next specific issue, you should be able to upgrade to the latest version and your problem should be solved. Then, one thing that came together with Java 9 is, of course, the whole modular system. And one of the things we wanted to have is a good solution for you Java developers to adopt this as easy as possible. So we have 3 steps. The first step is simply add your module descriptor, it's the module info.java file, to your source main Java, so to the source root of your project. Next, you need to upgrade the Maven compiler plugin to 3.8.0. And this is a plugin which is forwards compatible. So in case you are going to work with Java 14 or 15, it doesn't matter. This compiler understands the whole module descriptors. Step 3, there's no step 3. Well, I was at Java Land and I was using Eclipse and I forgot to save my POM file because in Eclipse you always have to save your files, of course. So let's do a small demo. I'm going to use a very old project here. And it is the Maven by Example book. It was, I think, published about 10 years ago, and there was this zip file with a lot of content in it. And one of the projects I want to show you is based on Spring and Hibernate, the early days. So if we go to this project and we say, let's run it with Java 13, and let's use the latest Maven version as well, and we do Maven verify. So now you will see that it won't build, and the reason is in this period, Java 13 didn't exist yet. With Java 9, your sources must be at least 6. And for Java 12, they increased it to at least 7. So now we have this issue. So we can do 2 things. We can say, okay, let's compile this with an older version. Or we can say, okay, nobody's running this project on Java 5 anymore. Let's push it to 7, 8, 9, or whatever. So let's do it first the hard way by saying, okay, this project still needs to be compatible with Java 5. What we can do is we can go to the website of Maven, and there's a plugin that is called Maven Tool Change plugin. And with this plugin, you can specify the location of your tools. So this is an example of such an XML file. So you specify that this is a toolchain for JDK, and per version you can locate all the executables of these runtimes. So what I'm going to do is I'm going to open this project. And here you can see it is using the Maven compiler plugin with source and target 1.5. And what I want to do is I want to copy this part into the plugin, into the POM file. And I want it to be between 1.5 and 9, just to be sure. Let's try it again. So for the fast readers, they can see that the toolchain plugin is kicking in, and it is also specifying which version of the JDK is being used. So every time you will see something like toolchain in Surefire, toolchain in compiler plugin, etc., etc., and it is also using. So now we are running Maven itself on Java 13 early access, and we are compiling and running the tests with quite an old version of Java. So that's pretty cool. And like I said, this is also possible when running it with Maven 3.0. So I can switch to Maven 3.0. And again, say Maven verify. So now Maven is still running on Java 13 early access, but we're using quite an old version of Maven. And you see exactly the same results. Pretty cool, right? So the next thing I said is about the model descriptor we can add. So I prepared one for this simple model, which is the domain model, which can be used to store stuff in the database. And what we can do is source main Java, create a new file here. You don't always have to use an IDE. This is something everybody can do. Module info.java. Are you sure? Yes. And if I can edit this, so I prepare this. Save. And now, of course, I have to remove the tool change from this POM file. So let's see what will happen right now. Of course, we want to have colors again, so we're going back to the latest version of Maven. Right. So now it is saying, okay, you're again trying to compile a very old project. And a module descriptor was introduced in Java 9, so we need to use at least 9 as the source target, or even better, we can replace this with the release tag. And we can say, okay, this must be Java 12 compatible. I can remove these as well. You don't need to, but you can. So who thinks that this stuff will compile now? Who thinks it won't? Who has no idea? This is interesting. Okay. So, what happened? The reason is that I'm still using an old compiler plugin, and in the beginning I said there are two things you need to do. You need to upgrade, or you need to set your version to add a module descriptor, but you also need to upgrade the Maven compiler plugin to version 3.8.0, because this is the one that understands the whole module system. So here we go. and you see that now the whole project is compiled. So you don't have to change anything about your dependencies, no extra flags or whatever. Just add this modular descriptor, upgrade the Maven compiler plugin, and it works out of the box. So with that, I think I demonstrated that indeed Maven supports all Java. So we are kind of finished for the presentation, right? Well, we could, but I'm going to tell you a little bit about the history about the Java modular platform system. So around the release of Java 9, we were in this kind of situation. So we had Maven and we had Java, and they were sitting next to each other. No real relationship. Maven was running on top of Java. Java didn't require anything. But then Java 9 came, and there's this small part that has to do with the module system that has some overlap with Maven itself, and that makes things quite tricky. So the goals of the Java platform modular system are reliable configuration and strong encapsulation. So for those who haven't heard this, reliable configuration is about ensuring that everything that you need to have on the compile time are also available on runtime. So these checks are done for you. And strong encapsulation is about being able to hide packages for other jars. So if you take a look at the module descriptor, this is a very short one just to explain how it works. So every module has a name, and with the requires you can specify which modules you depend on, and you can see some similarity between modules, Java modules, and Maven dependencies. And you can have strong encapsulation by saying, okay, these packages are exported and are visible to other jars as well. However, you should be very careful with it, because if you are just adding descriptors or generate them, you could really corrupt the whole Maven ecosystem. So this is a huge warning for especially library builders. They should be aware of the impact when they add these module descriptors to their jar files. On the other hand, application builders should recognize these issues as well, so they can help these library builders to improve the module descriptor. I was part of the expert group as well, and I was able to change a little bit of the specifications because these didn't work very well in a Maven ecosystem. So one handles the jars on the module path. One is about this special flag. It's called a module path. And then the next two are the most interesting parts. Those are about module names with numbers, actually ending with numbers. And the last one, and this is one that actually delayed the Java 9 release once, is about the automatic module names. So if you go into detail, I will handle the first one quite fast because they're not that interesting for you as an end user. But in the original specs, you could only add directories to the module path. Well, this is, in our case, a little bit weird, because if you know how the local repository of Maven looks, if you have this the folder with the version, you have several jars in it. It's not only the jars with the compiled classes, but there's probably also a Javadoc jar or a sources.jar. Whereas a Maven dependency, it explicitly points to one file. So we, to ensure that we could be reliable as that, we wanted this specification to be changed. And like I said, there are probably multiple jars in a directory. So this one has been changed, all quite early in the early days of Java 9. The old module path, it's a special flag. And we thought we needed that, but in the end we don't use it anymore, but it is still interesting. And in short, it makes all entries on the module path see each other. So normally you really must explicitly say, okay, this module can see that one if you don't have module descriptor. And with this, it is just one flag and they can see each other. Now module names. So this is one of the hardest parts, but when I noticed something about module names, I had this déjà vu. Because what is a proper module name? It is similar to the question, what is a good group ID and what is a good artifact ID? And especially the first time you were working with Maven, what is a group ID? What is an artifact ID? And in the beginning, you saw quite often that the artifact and ID and group ID were exactly the same. And after a couple of years, people saw the intention of this group ID. So one of the things they said in the beginning is that module names shouldn't end with a number. And the reason behind that is that the Jigsaw team thought that versions as part of the artifact ID were always used as a version. Well, in March 2017, we had a look at the Maven Central, and we came to close to 30,000 group ID artifact ID combinations that end up with a number. And these can be divided in 3 groups. So the first group are the projects or products that end with a number. So for some reason, the first 3 are Amazon products, and they like to end their products with numbers. Then you have C3PO, database driver, DB2. So if this would change, if the Jigsaw team would require that module names could not end with a number, you would have a weird situation here, because then it would be or DB and then 2 written, just because the specification says so. So that would be weird. The second group are versioned libraries, and Commons Lang, I think, is a good example what they did, because of this, it is possible to have both Commons Lang 2 and 3 on the class path, whereas if they would have been the same, Commons Lang 3 is not backwards compatible with Commons Lang 2. So by having 2 separate artifact IDs and separate packages, it is possible to have both of these artifacts on your module path or on your class path. And the last one is about, I would call them bridge libraries. And for instance, the last one is about Surefire. It should be possible to have multiple implementations of JUnit inside the Maven Surefire plugin. So they support Maven of JUnit 3 and 4 and 5. And they all have a separate jar. So in that case, it makes sense to have an artifact ID that ends with a number. So like I said, the original implementation did not allow to let module names end with a number. And this has been changed. So blah, blah, blah. And now it says, OK, we're going to allow it as long as people don't use it as a version number. But that's not something you can check. It is just that they specified it like this. Then the automatic module names. So automatic module names are jar files that don't have a module descriptor inside of it. But you should be able to use them on the module path. So there's a long list about how this automatic module name is calculated. And finally, it says the module name is otherwise derived from the name of the jar file. And it removes the version and etc., etc. And we said, OK, so this is going to cause issues. I'm not sure if you know about this, but this is about something that happened in the NPM world. And there was this library, it was called Kick. And NPM doesn't have namespace, because we're talking about namespaces in this case. So there was this quite popular library that was called Kick, but there was also a company called Kick. And they wanted both to deliver and publish this library. So they were arguing about it, and in the end, there was this developer said, OK, so I'm going to remove my Kick version, my Kick library from NPM, and do whatever you want. The moment he did that, tens or maybe hundreds of thousands of projects were broken, because it was quite a popular library, and because this issue with namespace, it wasn't possible to recognize if it was using Kick this or Kick that. So with this in mind, we said you should be able to specify something like a namespace also with modules. So you shouldn't just depend on the file name. So what we did is we tried to gather some evidence, and we have Maven Central, of course, which has a lot of artifacts IDs, and we had a look at it. And we came up with over 13,500 rows of collisions. But there are actually much, much more collisions. Okay, so we can remove a couple of these artifacts IDs, because the ones that are surrounded right now, these are just POM files. These are not jars. So we can remove them. However, all the other ones, you could put them all together on the class path. So for instance, an artifact that is called library. You could put all those 400 libraries on the class path. But if you put them on the module path, it will complain because there can only be one. So if you count that, well, it's probably closer to 20 or 30,000 collisions you can get. So we said in the beginning, from a Maven point of view, we said, well, you shouldn't rely on automatic module names, because sooner or later it will cause collisions. However, the Jigsaw team said, well, we need this concept, otherwise we cannot provide this whole module system to our application builders. So we had this dilemma, and we said, okay, so library builders should never refer to automatic module names and publish it to some kind of public repository, because otherwise you will get these kinds of collisions. However, probably most of you are application builders. You can refer to automatic modules because you are in full control. Nobody is depending on you because you are the end product. So with this latest Maven compiler plugin, it will also warn you in case you are referring to automatic modules. And it will also recognize if you are an application or not. And it's actually based on the exports. If you don't export something, you are probably an application. Otherwise, you are a library. And based on that, it can show you an informational message or a warning. And if you are using at least Maven 3.5, you have colors, and you will see it immediately. So this is the part of the whole theory about automatic modules. And for those who have been to international conferences, they see some kind of conferences how automatic modules should be applied. So there are also, you have library builders that are at the bottom, you have application builders at the top, but what about this group in the middle where are this kind of frameworks? What about this group? So this is the specification that is with the Java Platform Modular System, and one interesting piece here is it is interesting for large applications as well. Up until now I only know one large application that has full support of the Java Platform Modular System, and that is the JDK itself. I don't know any other large application that is really using the platform, because it is quite complex. And it will probably take years and years before the first real large applications are using this system. So this is an example what you see during the conferences. So you have this small application, it's called My App, and it is using a couple of libraries from Jackson, and it also has its own library, and it's all on top of Java base. Not really a real-world example. This is a real-world example. So you have your application, it's called My App. It has direct dependencies, but these direct dependencies also have other dependencies called transitive dependencies, and that could be a long list, and at the bottom there are these independent libraries that don't have any other dependencies other than java.base. So now I will show you how easy it is to corrupt the Maven ecosystem, and I can do it in 5 steps. So let's start with a library we want to generate. So it's called Currency 1.0. It's just a library working with currencies. It doesn't have a module descriptor, just a classic jar as you are used to. We want a buy service, and this buy service says, okay, we're in the Java 9 world, so let's add a module descriptor. And it knows here that it wants to use this currency library, but because it doesn't know the module name, because it doesn't have a module name yet, it says, okay, I'm going to use the name of the file as the module name. So it says here requires currency. After that, current says, okay, let's start a version 2.0, and we really are going to add this module descriptor, and we're going to call it org.modularity.currency. So it is different than the automatic module name. After that, there's also a sell service, because if we can buy things, we probably can also sell things. This also has a module descriptor, and it requires this org.modularity.currency module. So these are still third-party libraries, and then we have our animal market. We're not going to do a pet store, that's quite small. We're going to do an animal market. And we're going to use both these buy and sell libraries. So if we are going to redraw this, first, of course, we need a SPAN file. The group ID, artifact ID, version, whatever, and the dependencies look like this. The buy service and the sell service 1.0. If we're going to redraw it in a graph, you see it like this. And as I showed you, the currency or the buy and sell service also have dependencies. So the buy service is using currency 1.0, sell service is using currency 2.0. Well, what does Maven do? It says, okay, so there are two versions of the same artifact. So I'm going to pick the first one. And this won't compile, because the sell service requires this module with the name o.m.currency, and it doesn't exist anymore, because only the currency module is on the module path. And there's nothing you can do about this, just by referring from our animal market project, depending on these libraries, there's nothing you can do. Well, we could try one thing, and we could try to switch the buy and the sell service. So now the graph looks like this. So now we have the sell service on top, and that also means that the currency 2.0 is on top. Maven again sees there are two projects of the same artifact. Maven picks the first one, and again it won't compile, because the buy service requires currency module, and this one isn't there anymore. Even though you could say, okay, but based on the file name, it could calculate it, but the specifications say, no, every artifact can only have exactly one module name. So again, nothing you can do here. So who was wrong in this picture? Well, you probably guessed it, it was the buy service. And what it should have done is it should have added this manifest file and introduced this automatic module name. So in the manifest file, you can add this automatic module name and specify the name you want to give to your users. So if the buy service would have done something like this, it would be possible to give it away to others and just use this module descriptor. This also means that there is this point of no return. Once you start using module descriptors, you cannot go back to jars without a module descriptor, because the name can change and it will fall back to the file name based module name. So in the picture, it means something like this. So you cannot, once you use currency 2.0 with this specific module name o.m.currency, you cannot fall back to the original 1.0 anymore. So the strong advices are, once you start introducing these module descriptors, make sure that your project is Java 9 ready. And a couple of hints, there should be no split packages. Split packages are packages with classes that are separated over different jar files. That's not allowed anymore in Java 9. And you shouldn't have any classes in the root of your project, because you cannot export it anymore, so there's no control about it. For libraries that depend on at least one file name based automatic module, don't add the module descriptor yet. Start with this manifest file and specify there which you think will be the automatic module name in the future. Pick your module name with care, and the best hint we can give you is use the shared package you have in your code base. So don't use just library or app or whatever. Just pick up the package name so it is unique enough. Mistakes will happen, of course, and one of the first mistakes we saw was with ASM. There was a 6.0 beta released, and there were 3 artifacts which contained the same packages, which means that they couldn't be on the same module path anymore. They were aware of it, and they solved it by dropping all the special cases of ASM, and ASM 6.0 there's only one of it, so that's perfect. So of course there are some frequently asked questions, and one of them is, can every project become modular? The answer is no. Java 9 is a really game changer. It introduces new rules that weren't there in the early versions of Java. So if you said, well, okay, I'm going to put my interfaces and implementations in the same package, yes, then you will have right now not the ability to say, okay, I'm going to only show the interfaces and keep the implementations hidden from the rest. So in general, the advice would be just if you are on an old version of Java, don't start using the modular descriptors. Once you start with a new project, keep these new rules in mind, so it should be quite easy to switch to Java 9 with the whole modular system. And no worries, the class path will stay there forever. Mark Reynolds says so, and I'm pretty sure that a lot of projects are just not capable to switch to the module path. So, and this is one of the questions I always get, so I'm already going to give you this answer. Will Maven generate the modular descriptor for you? Because you have the POM file, there is already a lot of information in it. Should you be able to do that? Well, again, the answer is no. And one of the reasons is there are different purposes. So the POM file is used to download the jar files. So you have this coordinate to a specific jar file, it will download it, and it will be added to the class path for you automatically. The module descriptor is about ensuring that everything is available on the module path. So the purpose is completely different. Also, not all modules are available as dependencies because they are part of the JDK itself. So think about Java logging or JDK compiler. You cannot translate it into a dependency. There are also some elements in the module descriptor that are not covered. So for instance, what is the module name? Should the module be open or not? What are the packages that needs to be exported? What are the services I want to use or provide? You could say, well, why not change the POM file? Okay, so we could do that, but the whole issue is the POM file is not only used by Maven. There are a lot of tools that depend on the current structure of the POM file. So just simply adding elements will probably corrupt the whole ecosystem again. So this is also one of the reasons why the POM version 4.0.0 you have right now, it is there already for ages. I can give you a small hint. We are working on new specifications and to think about how to solve this issue. And once we have solved this, you can do quite cool stuff. Like I said, this POM 4.0.0 has no space for new elements. There's also another part. Who's running dependency analyze goal every now and then? Perfect. So what does this do? This one shows you a list of dependencies, and it can figure out if your dependencies are used and declared, which is good, used and undeclared. So this is not really that good because these are probably transitive dependencies. But the last one is a problem. These are the unused but declared dependencies. So for some reasons, you probably added it in the past, you forgot to remove it, you don't use that code anymore. So it's just there for no reason anymore. If we would generate this module descriptor based on the POM file, you would get a list of requires this and this and this and this. However, dependencies can be excluded. Required modules cannot. It's called required, so it must be there. So this is one of the reasons why we say we are not going to generate it. for those who know JDAPs, JDAPs can do it, right? Yes, it can. But it is based on the compiled classes. So first you have to compile it, then you can generate a modular descriptor, then actually you need to recompile it again to show that it really works with the descriptor, etc. Way too complex. So again, not a reason for us to do that. However, there are always open source projects that will try to solve this issue, and there is one. It's called Modetect, and Modetect is one of those plugins that can generate a modular descriptor based on the information in the POM file. But from my perspective, what you see right now is it's getting more and more advanced, and all the information you would normally put in this explicit module info descriptor file is now moving to the POM file. So I'm not sure what is better. Is it a long POM file or is it an explicit module info descriptor? It's up to you. So with that, the result is Apache Maven supports all Java. As I showed you, all the old Java versions are supported, as well as the newest ones. With that, I'm almost finished. I showed you one slide, but I will keep that until the end. Are there any questions right now? Yes, over there. We will get a mic first, so okay, everybody can hear it.
Assuming we have already existing large project and we maybe want to move to modulars, do we need to wait until all the libraries which we depend on are moved to modulars to perform this?
Like always, it depends. So, are you in full control of the libraries? So, are other projects depending on your libraries? If that is so, then I wouldn't add modular descriptors yet. But if you say, okay, it's within my company, I have full control over it, just start experimenting with it.
Okay,
yeah?
Thank you.
Yes, as I showed you, it's quite easy. Just add this modular descriptor file to your source main Java and give it a try. But you have to understand the whole specification of the Java platform modular system. It is not that easy. So I showed you the basic stuff, but there are a couple of flags you can add to it to make it work. Other questions? It's a small group, so I can understand. There's a question over there.
So I was just wondering, if you use Java 9 or later, can you disable this and not use the new module feature?
So you want to add a modular descriptor and still want to compile it, or?
Oh, so it's an optional. So you don't.
It's optional. Yes. Yes.
So what are the benefits of using it?
Oh, this is okay. So this is really interesting. If you want to start using Java, let's say 11 right now, because that's long-term support, you don't have to switch to the module system. It is there, but you don't have to use it. You can still build your classic applications. What I did in the beginning, I picked up this very old example from the Maven by example book. There was no descriptor in it, and I was capable to build it with Java 13 early access. That is still possible. You can do it right now. So that shouldn't stop you from starting to switch to the latest version of Java. You don't have to stay on Java 8. I'm pretty sure that most of the people here are still on Java 8 and don't dare to start to 11. Because I think they did a little bit of bad marketing, because the whole focus was on this whole modular system. But there's much, much more in Java 9 than just the modular system. So right now you can already switch to Java 11 or even better 12. More questions? Otherwise, I'm going to move to the latest slide, the last one. That's this one. So I'm doing this kind of talks now for a couple of years, and every time I talk with some of the attendees, they are kind of surprised. And one of the reasons is that they are not aware about how the whole Maven project works. So Maven is used about 60 to up to 80% of the Java projects or Java developers. It all depends on how you ask your question. If you say, okay, so what is your main build tool? It is, then it's probably closer to 60%. If you say, are you using Maven? It's closer to the 80%. Maven is not only the binary you have on your module path. There are right now up to almost 95 sub-projects. Most of them are all the plugins we have. But we also have something like SCM for source control management. We have Wagon for transport. We have all kinds of libraries. Surefire is quite a huge project. It's not only the plugin, but also the things behind it. Like I said, it's close to 100 sub-projects that we are trying to maintain and to make it better for the Java ecosystem to work with Maven. And this is one of the things that most people surprises, because Maven, there's no company behind it. Some people thought that Sonatype was behind it. It is not. So Sonatype is hosting Maven Central, and they're doing a great job, but they're not investing in Maven itself. Maven is maintained by 5 to 10 active volunteers. So they're not getting paid for it. They're just having their daily job, and after that, in the weekends and in the evenings, they are working on Maven because it's their passion, and they really think that they can add something to it. So I would prefer to restore the balance, and for that, we introduced this label. It's called Up for Grabs, and you can make a picture of this, or just get the slides afterwards. And this will send you to a Jira page with some issues where we say, okay, these are small, simple issues that could be solved by a good Java developer. Most of the times, these aren't really Maven issues, but just Java puzzles. And this is a way to get familiar with the whole open source project. And we can guide you and to help you improve your pull requests. So in general, all the Apache Maven projects are also available at GitHub. You can make a clone of it, fork it, and provide a pull request, and we can guide you in improving your pull request. And in the end, we will accept it probably, if this is a good thing, of course. And we can add you as a contributor as well, because we really like to have more contributors. And if you are a good contributor, you can even become committer or a chairman like me. So here's also another link. This is a guide, committer school, and here we summed up how we, as a Maven developer, evaluate every pull request. So it is about checking if there's really a bug. If I remove the test, will the issue be there or not? Is it really fixing the issue or not? So this is a good page to see how we kind of verify all these pull requests. So if we have enough pictures of it, I would say thank you very much for attending this presentation. Thank you.